Welcome to this beginner-friendly guide on C-sharp FIFO and LIFO data structures, essential concepts for any developer. Understanding these will significantly improve your programming skills. FIFO stands for first in, first out, meaning the first element added to the collection is always the first one to be removed. This ensures a sequential and fair processing order. Think of it like a line at a coffee shop. The first person to join the line is the first person to get their coffee and leave. This perfectly illustrates the FIFO principle. LIFO, on the other hand, means last in, first out. This principle dictates that the most recently added element is the very first one to be removed, reversing the entry order. Imagine a stack of plates. You always take the top plate off, which was the last one placed there. This clearly demonstrates the LIFO principle in action. These structures are fundamental for managing data flow and processing order in various programming scenarios, from simple applications to complex systems. They provide predictable behavior. Now, let's dive into how C# implements these essential concepts using its powerful and convenient built-in collection classes, making development much easier and more efficient. For implementing first in, first out behavior, C# provides the highly efficient and easy-to-use generic Qt class. It's designed for elements processed in arrival order. To declare and instantiate a Qt, you specify the specific data type of the elements it will hold within angle brackets. This ensures type safety and prevents common errors. Here, we create a queue to store string values, which is a common use case for managing a sequence of messages in an application or processing log entries. The primary method for adding elements to a Qt is enqueue. This method efficiently adds a new item to the very end or back of the queue. Visually, this action perfectly mirrors our coffee shop analogy. It's like new customers arriving and joining the very back of the line, patiently waiting their turn. Conversely, the dequeue method removes and retrieves an item. It specifically targets and removes the item that has been at the very beginning or front of the queue for the longest time. This is our coffee shop customer finally reaching the front, receiving their coffee, and happily leaving the line, making space for the next person in sequence. It's crucial to note that if the queue is empty and you call dequeue, it will throw an invalid operation exception. Always check count before dequeue to prevent runtime errors and ensure robust code. The peek method offers a convenient way to inspect the next item in line. It returns the item at the beginning of the queue without actually removing it, useful for conditional processing. Continuing our analogy, using peek is just like subtly glancing at the person at the very front of the coffee shop line, observing them without them leaving or being served. A helpful tip: Qt is ideal for scenarios like processing tasks in strict order, managing print jobs, or handling network requests, ensuring fairness and preventing bottlenecks. When designing your application's logic, it is critical to carefully consider the required order of operations. This guides your decision between a FIFO or a LIFO structure. Having covered FIFO, let's now shift our focus to the stack T class, which is specifically designed and optimized for implementing the last in, first out behavior in C# applications. The stack T class in C# is the primary way to implement the last in, first out principle. The last element added to the stack will always be the first one retrieved. Declaring and instantiating a stack, T, is similar to a queue. You specify the precise data type of the elements it will contain within angle brackets, ensuring type safety. In this example, we are setting up a stack specifically configured to hold and manage integer values, useful for tracking numerical operations or managing sequences. The method used to add elements to a stack, T, is called push. This operation efficiently places a new item directly onto the very top of the stack, making it most accessible. This action perfectly illustrates our plate stack analogy. It's like carefully adding a new plate to the very top of an existing stack, making it the first one you'd grab next. Conversely, the pop method is specifically designed to remove and return an item from the stack. It always retrieves the item currently positioned at the very top. Just as we take the top plate off the stack, pop retrieves the most recently added item. This ensures the last element that entered is the first one processed. Similar to dequeue, attempting to call pop on an empty stack, T, will result in an invalid operation exception. always ensure the stack has elements before attempting to pop. The peek method provides a safe way to examine the next item. It returns the item at the very top of the stack without actually removing it, useful for making decisions. This functionality is incredibly useful as it allows you to inspect the next item that would be processed by a pop operation without altering the stack's contents or order. Helpful tip: Stack T is excellent for scenarios like implementing robust undo/redo functionality, efficiently parsing expressions, or managing function call orders in a program's execution. A deep understanding of when to use a queue versus a stack is crucial for designing efficient, logical, and maintainable programs. Choosing correctly impacts performance and clarity. To solidify our understanding, let's now summarize the key differences between these two powerful data structures and highlight their most common applications in C# development. FIFO, implemented by the Qt class, strictly processes elements in the exact chronological order they were received. Older items are always handled before newer ones. This characteristic makes FIFO structures perfect for maintaining strict order and ensuring fairness in task execution, such as processing user requests or managing system events. LIFO, implemented by the Stack T class, processes the most recent element first. The last item added to the collection is the very first one to be retrieved. This behavior is ideal for operations that require backtracking, like navigating history or processing data in the exact reverse order of its arrival, common in recursive algorithms. Both Qt and Stack T conveniently offer a count property. This allows you to quickly check the current number of elements within the collection, essential for managing state. Furthermore, both collection types also provide a clear method. This offers a straightforward way to efficiently remove all elements, effectively resetting it to an empty state. As a critical best practice, always remember to proactively handle potential invalid operation exception errors by checking the count property before attempting to queue or pop. Another important tip for performance-critical applications: it's highly beneficial to understand the underlying data structures that Qt and Stack T utilize internally. While Qt and Stack T are generally efficient, understanding their internal workings and how they manage memory can unlock further optimization opportunities for your code. For example, Qt internally employs a circular array for storage, allowing efficient operations. Stack T typically uses a simple array, managing elements from one end. Because they use arrays, resizing operations can occur when capacity is exceeded. Frequent resizing might introduce a slight performance impact if not managed effectively. A smart strategy to mitigate this is to pre-allocate an initial capacity for both Qt and Stack T during instantiation, avoiding frequent and costly resizing. This pre-allocation technique is a very good practice for applications where you have a predictable understanding of the typical data sizes your collections will handle. Another advanced tip: for multi-threaded environments, consider using concurrent Qt and concurrent Stack T. These specialized classes are designed for safe concurrent access. These concurrent versions are inherently thread-safe, preventing data corruption and ensuring consistent behavior even when multiple threads access and modify them simultaneously. Always choose the right tool for the job. Standard Qt and Stack T are perfectly sufficient and often more performant for single-threaded applications. In summary, FIFO and LIFO are fundamental and incredibly powerful data management principles that underpin many efficient algorithms and application designs in computer science. C# provides developers with robust, highly optimized, and easy-to-use implementations of these principles through its Qt and Stack T generic classes. To help solidify your understanding, always remember the real-world analogies: a queue of people for FIFO and a stack of plates from which you take the top one off for LIFO. Mastering these fundamental data structures and understanding their appropriate use cases will significantly enhance your ability to design efficient, reliable, and maintainable C# applications. The best way to internalize these concepts is to keep practicing. Experiment with code examples and try solving problems using both to solidify your understanding. Thank you very much for watching this comprehensive tutorial on C# FIFO and LIFO data structures. We hope you found the content valuable and easy to follow. We sincerely hope that this guide has successfully provided you with a clear, practical, and actionable understanding of these fundamental and indispensable concepts in C# programming. Now, go forth and continue exploring the vast possibilities of C#. Keep building amazing, innovative, and efficient applications, leveraging the power of these data structures. Happy coding!